Hi there, everybody. We are going to continue our lectures on carboxylic acid derivatives here. And now we are getting to the ester portionality. So we've discussed carboxylic acids. We've discussed the acid chloride functionality, which is the most reactive of the bunch. We then discussed anhydrides, which we kind of breezed over a little bit because they have very similar reactivity to that of the acid chlorides. And now we are getting ready to start talking about esters. So esters can undergo some other reactions like Grignard's and the double reduction as the acid chloride does, but what we're really going to focus on here is a set of reactions that are unique to esters in the next several lectures. And the first one that you may have come across, it's very common in undergraduate labs, is the Fischer Esterification. Now I put end hydrolysis here because the Fischer Esterification is the process of turning a carboxylic acid into an ester. But it is a completely reversible reaction. There's some serious equilibrium going on here. And it is very possible to drive the reaction backwards, in which you take an ester and it undergoes hydrolysis in order to provide you with a carboxylic acid. So these are basically the two different sides of the same coin, so to speak. When you're talking synthetically and mechanistically, they are reversible pathways to one another. So we'll take a look at the Fischer esterification, and then we'll just briefly discuss or talk about hydrolysis, which again is the reverse process of this. All right. So in order to start out, we would take an ester. Remember that esters are going to have the general form R, C double bond O, and then you're going to have an OR of some sort. All right. Now, when you have the ester, this reversible reaction is going to require two things. You're going to need, I'm doing the Fischer esterification. So we want this to be a carboxylic acid. I was already jumping to the hydrolysis. Okay, reversible, and the goal is that we're going to get an ester out of this. So we're going to have R, C double bond O, and then in place of the OH, right, we would have OR. And I'm going to put just a double mark there so we realize that this R came from a different source. Okay, now in this case I need an alcohol. That's the first thing that I'm looking for. So here's my double prime alcohol, and this is going to be the result of that OR group that's there. And I also need an acidic catalyst. So remember, a catalyst will regenerate itself by the end of a reaction. So we should find H plus / H3O plus somewhere when we get towards the end of this reaction. All right, now, similar to aldehyde and ketone methodology, when you have acidic conditions, the carbonyl will go ahead and grab one of these protons in order to protonate itself. Okay, so you're going to see the double arrows all along because this is all reversible. And what we end up with is what I like to call the activated carbonyl, right? Because you've got a plus charge on that oxygen that's really creating a partial positive because now the oxygen needs additional electrons and it's already very electronegative. So in that case, right, we still have the OH here. We are now going to very readily accept whatever our alcohol is. Okay, so the alcohol functionality is now going to perform a nucleophilic attack on this carbonyl here that's got the partial positive. And the pi electrons are going to go up to the oxygen in order to satisfy that formal charge. Okay, so the new formal charge is really going to be brought to the alcohol that is coming because it's bringing its proton along with it. So reversible step, we now have the RC. Now this has become an OH at the top here. Okay, and we have an ORH. This has the positive charge on it right there. And then we still have an OH here. So this is not identical to, but it's very similar to the acetyl / hemiacetyl formation when you're doing this with ketones, because these conditions would end up doing sort of an acetyl formation with ketones or aldehydes. So it's a similar pathway. But again, we have the two OH groups because of that carboxylic acid, whereas in a ketone or aldehyde, this group right here would be an R or an H, and that's the big difference there. Okay, so as we continue along, the next step, now you can show this by getting the proton to leave and to actually transfer it, but a lot of times I just like to write H transfer. Okay, so what's going to happen is the proton right here is going to give electrons back to this oxygen, and one of the two OH groups is going to pick it up to form water. So what you're essentially doing is you're releasing a proton into solution from that alcohol that attached itself, and then you will also have one of the alcohols up top that's going to pick up a proton. So the proton has just been transferred from one functionality to another, and that very often is referred to as proton transfer when you're looking at reactions like this. Right, now I'm going to have the alcohol on the side here pick it up. You could have picked either of these, it doesn't really matter. Okay, and now this would be OR down here. This is back to its regular state. We no longer need to worry about the formal charge there. Okay, now, in this case, water will leave. Again, this is similar to the acetyl reactions that we've seen. So water is going to leave in this case. Okay, and then this OH will go ahead and reform the pi bond. So that was originally a pi bond over here in this step, and so we're just simply reforming that pi bond. Now that carbon's letting go of something, instead of a carbocation directly forming, we're going to go ahead and we're going to reform that pi bond with the oxygen. All right, so we have R, oops, C, now this is double bond at this point, O, H, it's got the plus charge. Okay, now remember water left, so now we have the OR. So we're real close to that ester that we have up there. And let's keep in mind, because I've been losing track along the way, right? This is the R prime. This all came from the alcohol here. Okay. Now, when we take a look at this portionality, we had water leave in the last step. So H2O left, and H2O can act to grab that hydrogen and give these electrons back to the oxygen with the formal charge. And there we go, we end up in the ester form. Right? Now, hopefully you can see the reversibility of this reaction really comes from the fact that we're playing around with alcohols versus water leaving. Because if I wanted to reverse this, all I would need to do is say, give me water in acidic conditions, and then the acidic conditions would protonate the carbonyl over here. And once that carbonyl is protonated, water would attack, and then the proton transfer would occur to the alcohol, to this OR group, right? I'm running it back in reverse. And then the alcohol that's protonated would leave, and that would leave the OH group. So hopefully you can see the reversibility, which we would call hydrolysis, of this reaction, all right? Now, again, if you wanted to create the hydrolysis conditions, I'm not going to run through the whole mechanism because it's just the reverse of what we have here. But I will clear the board and show you the proper mechanism, which is actually, I'm sorry, the proper synthesis, which is what I was originally writing, and then I caught myself because we were doing the Fischer esterification. All right, so what you just saw was the Fischer esterification. The hydrolysis is simply going to be the reverse of that. So I start with the ester. So let's say the one that I just formed, right? I've got this ester. And then if I would like to take this ester back to the carboxylic acid format, I would need H plus and H2O. Okay? And then that would lead to R, C double bond O, OH. And hopefully you can see the point that I wanted to sort of bring across here was that this is completely reversible because look, I'm grabbing this, right? I would go down and I would create the activated carbonyl complex. All right, so this is a plus now, and then this is an OR. Okay, so in this case, the water would then come and attack. And if you look at this in comparison to what we just had, this is the complete reverse of what we just did, right? So the water would add, and then once the water adds, you would get a structure that's going to look like this. So the water brought two protons with it, right? Here's the OR, here's the OH, and then what's going to happen here is proton transfer, right, is going to create a situation like this, where the alcohol picks up the proton, and now this is OH. So the alcohol will leave, And then the same general finishing process is going to occur where you'll get one of the OHs to reseal, and then you can get your acid back because it's an acid catalyst. So that is the Fischer esterification and the hydrolysis process. Reversible reactions, they're complementary to one another. They balance each other out. All right. Now, one of the next things we're going to talk about is there's another way to turn your esters into carboxylic acids, and that is through the process of saponification. And that's one that students are also interested in, because another common lab or theme that you get to in this chapter is the idea of creating soaps. That's where the name of saponification came from. So if you're interested in that, stay tuned, because we will have a lecture on saponification and the process with that, because it is a little bit different than what we're dealing with here. So hopefully everybody found this useful. As always, just help out the channel. If it was useful, you can leave a like. If you comment, I'll try to get back to you. And again, subscribing will be the quickest way that you can get access to all the new material on YouTube. If you wanted to support our channel in any other way, you can always check out the links for my Udemy courses, which I'm continuing to expand, especially as we approach this winter break. So there's lots of good content there. It's very cheap. It's cheaper than a pizza in order to sign up, and you get full access. You can email me directly with your questions, and you will get a full set of tutoring videos with practice problems for the given unit that you sign up for. So we've got aromatic reactions, alcohols, all sorts of stuff there. So check it out. It's really useful. So I will see you guys for the next lecture. Take care.